So we're going to look at 7.2 absolute value functions. And before we start discussing it, I just want to go over the graph that you have in front of you. The blue part is your absolute value function. It's the graph of y is equal to the absolute value of x. Okay, and the red part, which actually extends above the x-axis, because this part of the graph is really blue on red. Okay, so it actually does extend above the x-axis. This is y equals x. Okay, so the vertex is right here. It's at 0, 0. So our vertex divides the graph of this absolute value function, y equals absolute value of x, into two distinct pieces. One part is the part that goes up to the right, and the other part is the part that goes up to the left. An absolute value function is a function that involves the absolute value of a variable. So in this case, the absolute value of x. Okay, so the following explanation is for absolute value functions. Okay, so for all values of x less than 0, okay, so that means everything to the left of the origin, the y value is negative x. Okay, so what that means is that this part of the graph is y equals negative x. For all values of x greater than or equal to 0, so that means from the origin and up to the right, the y value is x. So that means that this part of the graph is y is equal to x. Since the function is defined by two different rules for each interval in the domain, you can define y equals absolute value of x as the piecewise function. Okay, and we're talking about y is equal to, and then we use this parentheses, x if x is greater than or equal to 0, and y is equal to negative x if x is less than 0. Okay, so this is a piecewise function. Okay, and what it means is, if you go to the right of the screen, a function composed of two or more separate functions or pieces, each with its own specific domain, that combine to define the overall function. Okay, so we have two pieces here. We have one where y is equal to x. Its domain is that x is greater than or equal to 0. And the second piece is y is equal to negative x if x is less than 0. Okay, so you can see that our absolute value function is made up of two separate functions, y equals x and y equals negative x. Okay, now I'll just read this explanation and then we'll go back up to the graph. The graph shows how y equals the absolute value of x is related to the graph of y equals x. Since the absolute value cannot be negative, okay, and we mean the absolute value of x, the part of the graph of y equals x that is below the x-axis is reflected in the x-axis to become the line y is equal to negative x in the interval x is less than 0. Okay, so we go back up to the graph. Okay, and because the absolute value of x can't be negative, the part of y equals x which is below the x-axis gets reflected above the x-axis. So this part of the line is going to reflect over the x-axis. Okay, so we'll just make a note of that. Reflect over the x-axis. Okay, and if we use our vertex as our center point, right? And then the part that gets reflected over the x-axis is where x is less than 0. Okay, remember everything to the left of 0 means that x is a negative number, so less than 0. Okay, the part of the graph of y equals x that is on or above the x-axis is 0 or positive and remains unchanged as the line y equals x in the interval of x is greater than or equal to 0. Okay, so that means that this part of the graph, y equals x, is true when x is greater than or equal to 0. Okay, and y equals negative x for your absolute value is true for when x is less than 0. Okay, so you can see this is where your piecewise function comes in. All right, here and here.